phone. Hello. Yes, here we are. We made the weekend. So, going to do some streaming. Friday streaming. Good stuff. I had meant to do some streaming this week of my Acorn System 1. But there's a problem. That's not good. So here is my restored Acorn System 1. So I got this off eBay a while ago. You know, I should probably, if I'm doing this, I should probably set up a view which just has the camera. So let me just do that. It's probably a good idea. Cam only. And then, you know, I really should do a better job of organising my scenes, you know. So let's see. Video capture device. And then, you know, maybe we can do that, and then I can go properties, custom configuration, because I mean, you know, it's like that. Whoa, it's always the same. There we are. Ta-da! Nice. I'm in my shirt because I've been at work today. So that's the way it goes. Working in lockdown. So what was I thinking? This. Is that all okay? I want to see if I switch back. Oh. You have to see about how it switches between scenes on the camera. I don't know. I have to figure that's the problem. Anyway, I was saying this is my Acorn System 1. You might notice it's missing a display, but that's okay because here's the display, and I can just plug that in. Story behind this, like so, and now you've got the, not with the original ribbon connector, but I made a decision to have this solution because the story is around 2016 or so. I'm going to move this here because one of the things I've got the display for. Look at that. Now if I move that here, then I'm able to see where I'm looking in the camera when I'm showing you this, and it's a bit more like on camera, right? Lockdown hair, lockdown beard. I might do something about that this weekend. Anyway, so I bought this off eBay about 5 years ago, and I was really disappointed to find that although it basically ran, it had a damaged LED in this. And this, if you can see there, this is an old style, getting focus camera. Ooh, maybe the camera focus is not, doesn't look like it's on automatic. But this is from my experiments because I wanted to stream development of see how it says autofocus is on. Let me turn it off and on again just to, because it's probably not really on. Come on camera. Here, I don't know. Can you see that? Focus. Yes, it seems a bit crummy to me. Anyway, that display is an original display that I managed to find someone who was selling a new old stock, so I could replace this unit. Now they're quite difficult to find, and it wasn't cheap either. But what you're going to do if this is kind of rather critical. Yeah, a lot of the other components are quite easy to locate. This one, but I found it, and then the problem was how to reattach it. The other problem with it was that, you know, it had a ribbon cable. The ribbon cable on this one, when I bought it, didn't have the original ribbon cable, and it was a bit of a mess. And it didn't survive the desoldering that was required to get a new one of these. So that was a problem. Another problem was that the keyboard was dodgy. I mean, the way this is made is there's the PCB that this is resting on, this top PCB, has got traces on it. Hey Mike, how you doing? I'm not going to be programming. I'll explain why. There's been it's really annoying, but I'm giving you the story as to why I'm not going to be doing it yet. I'm waiting for some components and then I'm going to do it. But yeah. So this PCB under here has got traces on it for the buttons. This thing, when it was originally designed and manufactured, was 1979, I believe, and I got one. The original one I had, my parents bought it for me. I do not have any more. I do not know where it went. I do not know what happened to it. It's disappeared. But probably in the move, my parents moved to Italy. So I don't know. We don't know what happened to it. Probably got thrown out. Aha! These are so difficult to find. They're really rare. And I'll show you how rare this is when you find out which one this is. I waited on eBay. I checked eBay. It must have been for years I was checking eBay to see if one of these would show up. And eventually one did. And it was a buy it now, and I just bought it. Because I wasn't going to wait anymore. The one that I had a white panel here that was a plastic panel. And they look a bit better than this one, to be honest. I'm not sure which one came first, if it was that one or this one. They're kind of two variants, so the difference is this panel. This one has a metal plate on it. Okay, so underneath there are these traces, and the traces have space for a 3-pronged dome. And that dome has a center which makes a contact when you press the button. And those, you look at the manual, it said you need to put these on. You had to build this yourself. You had to put these on the PCB, and there was an L-shaped sticker that you had to put over the top. And it was a nightmare because they would move. It was actually really difficult to construct that flipping thing. So you've got then a sort of vinyl sticky back plastic sheet that went over the top, and then these keys, they go over that, held in place by this plate, and when you push them you can hear it makes a nice, ooh, that's very loud. It caused it caused everything to go red. Anyway, so the problem was, of course, that these were old, dirty. The contacts were not good, and I had to remove this plate anyway in order to deal with the display. And the nature of this is, even if the display had been good, I probably would not have risked taking the display off. Because the reality is, to clean the keyboard up, I'd have had to take the display off, and that would, and it taking the display off with the mess of cables that damaged the display even more. I mean, like it messed up the traces. I also didn't have the right equipment at the time. I do now. Well, you can see here this stuff on there, that is exposed in the design. You see that soldering. So if this is all messed up, it really looks ugly. So And it did look a bit ugly anyway, so I took the opportunity. I had this new one, and it's like, what to do? Well, I dismantled it about 5 years ago, and it remained in a box. So since then, I had Kickoff Revival, had the debacle of that, and then after that I moved to the UK, and I had 2 years where this was in a box in the Netherlands and not here. And then we've had the lockdown year, and I needed to make space. I didn't have any space to work, but recently I've started doing some electronics again, which is really nice. I enjoy. So, okay, job to repair this. So I cleaned the board and got rid of all the gunk on it. I put the things on, and there was the question though. This was a big question, was like, how do I repair the keyboard in a way that's maintainable? I originally ordered some new vinyl plastic on there, and it was like, how am I going to put these on though? It's going to be a mess. And then, you know, it's like, and if you get the plastic touches the contacts, then it's going to get residue on them, and so on. You know what I've done? I use sellotape. Now that would be insane normally, because the solution I would need to be one that I'd never need to go back to it again, because this display soldered on the top, and it's the design problem of these things. They were never designed to last, to be around 50 years. They were very cheap. They were like £65 for this in 1979. So £65 in 1979 is quite a lot of money. So this was still, you know, but it was never really designed to last all this time. So you can see the problem is that if this was soldered on, there's no way to get to the display, to the keyboard for maintenance. And then the question of how to put those on and what kind of plastic to put on there, something that would last. It was, you know, so then I was looking for, can I find a cable for this display that is authentic? You can't get them anymore. I found something called Flexi Strip, which is very close looking to this. And so I almost went, and I bought some, and I have it. I almost went to the point of soldering that in, and I just didn't want to do it. Why not? Because if I soldered it in, I'd never be able to fix the keyboard again without unsoldering it, and unsoldering it would cause damage to either this PCB, which is ready, it took a bit of damage anyway, you can get rid of the mess that was there, or causing damage to this display. So I said, okay, I have to make a compromise here. Instead of trying to restore this 100% like the original, and in any case, this was built by somebody, so original is questionable. You know, these were kits. This was built by somebody originally, right? You can tell from the quality of some of the soldering. But I decided, no, I'm going to put these on here, and I had this solution with this thing. It's a little socket, and it plugs on, and it looks nice. The angle I got by literally just sticking it in at an angle, and with a little bend on it, and you know, it's absolutely fine. And then this means that now, if I need to do any maintenance on this keyboard, I can. I just take this off. I can unscrew this, dismantle it completely. The other side of this that I did was, there is, I don't know if you can see in there, well, it's a bit difficult to see, but on here, that connector wasn't part of the original thing. What it had was a ribbon cable, a very ugly one, which again you can't get replacements for, and it went into here and across the whole length of this over to this side, where you can see this connector. And if we look down there, you can see that I've got one of those row of pins, and so there is actually a ribbon cable that I wired, which needed to be just the right length so that it would fit in here. And this means that if I separate the two boards, I can detach them. And that was these kits you couldn't. That was another problem because they were just soldered in, and that's a nightmare. But like this, and there's just enough room, so that worked, and that's the story. Oh, but then continuing the story, because everything was fine and it runs, and I was able to do sort of like a duck shoot. I typed duck shoot in from the manual. That's the first video game I ever played. It was a video game. It was displays on this display, calculator display. The first computer game I played that I typed in the code from a listing was on this around 1979 when I was 13 actually. So it would have been first half of 1979. As soon as they came out, I got one because my parents very kindly bought it, and so that's where I started my journey in computing, with one of these. So there was more things that happened this week. A tragedy. This connector here, I damaged it. It was really annoying and it was a stupid mistake, but I've lost the traces on there. In part, you have to remember that these things, they were soldered in. Somebody soldered wires in here, and they ran off to the cassette recorder. This is the cassette recorder port. Okay, so I found a solution, which is this connector, which plugs in. You can see the traces are missing. That's sad, but still got them underneath. But hey ho, lesson learned. The thing is, it looks okay. It actually looks better than it did before, even in spite of that, because there's this little connect. And so what I can do is plug onto here and make an adapter, and it can go to a cassette recorder. Because again, the originals of these, nobody ever had a connector for these, so people would just end up soldering wires onto it. They would also solder wires onto the capacitor in here. There is a electrolytic, which I didn't change, and you see pictures of these with these red and black wires often sticking out, where people just soldered on and they connected it to a supply. So I thought that's no good. So what I've got in here is an actual cable, which I can't get out right now. Oh, I tried to glue this connector in with hot glue, but the problem is, there we go. The problem is that it was on the heatsink of the voltage regulator. There's a voltage regulator in here. They just melted the glue, and then the connector came off, and it just got stuck again because there's still a bit of glue on it. It's not a big deal. I might glue it onto the top board. No, I don't know. I have to just leave it loose is probably the best thing. So this cable connects to the voltage regulator, and so I can plug a supply onto here and minimize, distress basically. So day before yesterday, I said I want to stream this. I really want to stream live development of this. I'm going to do that. I want to relive the experience and go through the experience again. I don't remember all the details of programming this. I do remember some of the opcodes and how a lot of programs that I checked and what it meant, because I didn't remember quite what it meant. But the opcodes A91F850E, very common sequence of 4 bytes to begin a program with, and DuckShoot uses it. And basically what it does is it tells the operating system to not wait for keyboard input, to allow you to make a call to the operating system that displays on here, and it doesn't stop until you press a key. So this allows you to do animation on that little display. A91F is load accumulator with 1F in hex, and 85 is store accumulator at address 0E. This has 1K of RAM, that's all, of which the first 256 bytes are actual special RAM, which can be accessed using shorter instructions. So A91F, which is just immediate load of 1F to the accumulator. 85 is store the accumulator, whatever is in the accumulator, at address OE, which is address 14 in that first 256 bytes. When programming a 6502, you treated the first 256 bytes as almost like registers, fast access. You could access the rest of the memory too, but that is with slower instructions. So you've got 256 bytes of that memory. Then there's the stack. The stack is fixed always between 0100 and 01FF, and that never moves. And you've only got 256 bytes of stack, but you can use that for memory as well if you want, if you don't need it all, but that is fixed stack. And then the rest of the memory, all 512 bytes of it, you can use for your for your code. And if you wanted to, you could expand it, because this connector, the originals didn't have this connector, but there was the space to put one. So whoever had this originally added this connector is from they got it from Radio Spares, because there's a Radio Spares thing and a part number. I don't know if you can still get these types of connectors, Euro connectors they're called. You could plug this into a backplane, which would allow you to connect other peripherals. This exposes nearly all of the CPU bus connections. So you could plug an RAM expansion into this if you wanted to, and up to the maximum of 65K, which is the maximum amount of memory that you can have on a 6502, unless you do other clever stuff like banking your memory and so on. But the basic architecture, that's what you've got. So anyway, I wanted to do some programming on this, and I intend to, but we have a little bit of a problem, because the cassette port doesn't work. So on night before last, I would set up everything. I figured out a camera, how to put a camera in there so I can see the display, you can see the display as well. Very exciting. I intend to do this like hardcore with maybe not a cassette recorder, but I will be recording the audio output to the computer via the sound card, whatever. I have a cassette deck, but I think maybe we could go with that as well at some point, but it feels like that's just going a little bit too far, at least initially. So what happens there is that this has there are 4 pins, both 2 ground pins, and then one is for the cassette in and the other's cassette out, and it uses frequency shift keying as 2 frequencies, 2 tones, one to represent 0, the other to represent 1, and that sound is recorded on a cassette tape normally. In this case, I hope it will work if I record it with something like Audacity or whatever, even whatever, and just record that signal, and that allows you to save and restore to the memory, because otherwise it's got no static memory. I mean, no, it's volatile memory. When you turn it off, you lose it. And then not only that, but even if you had battery backup on it, yeah, you write a program and it crashes, it has that, it can decide to wipe out and erase your program. It gets very annoying. So what you would have to do is back up your work to the cassette. And I don't want to start working on this unless I can save. And I was thinking about, can I rig something up? And no, it's not worth it. I'm going to wait for the components to arrive. I've basically reordered all of these. Only cost about £15. These components are not hard to get. Some of them are a little bit, you know, 4024 is a little harder to get, but you can still get them. Basically two of the 4024s, these are CMOS static chips, CMOS. They're CMOS chips as opposed to TTL, and they're sensitive to static. And of course, this is, I don't know what this been. I actually theorize that at some point somebody working on this had a loose power connector because they were rigging this up, and it went and hit the display here and blew one of the LEDs, because why would it blow? So I suspect that happened, and then probably fell from here onto these two chips, or these two, I think it is, where two of these are blown. I verified that. They're the ripple counters, 7-bit ripple counters, which are used to generate, to take the clock signal and reduce the frequency down to tones that will be actually recorded. And you can get the circuit diagram of this, and I was just going over that, and it's quite an interesting circuit. So it basically downgrades the signal by dividing the clock frequency to get a lower frequency, and then further divides it down with a select between the higher and lower frequencies, and that goes out. The signal coming back goes through an op amp, which is this guy here, and then from there goes to another the same chip, the 7 stage ripple counter, but what it does is it takes a feed of an intermediate frequency between the two frequencies, drives that, which I think is this one, drives that, and what the signal from the tape does is it operates the reset on it. So basically, if the tone is faster than the reference, it keeps resetting it, and you get a 0. If, on the other hand, the frequency coming from the cassette tape is slower, this gets a chance to actually trip, and then you get a 1. So it was quite interesting. But anyway, I'm getting all the new chips. Until I have the new chips, I can't. Oh, it would survive drop on the floor. Until I get a new chip, I cannot. The new chips in here, I cannot actually record and restore anything, and I really would find that irritating. So we'll have to wait a little bit longer. I was really looking forward to doing that, but there you go. So restoration of the Acorn System 1 has finished. I didn't want to stream, that's too stressful, and these are really rare. Go and look on eBay, there are none. If you have one, you can probably get good money for it. It's difficult to say how much they're actually worth, but we're talking probably around, you know, £800 or so at this point, because there are people who really want them, like me, and they're very difficult to find. You can actually get replicas though. Somebody created a replica of it, you know. So that's the story of this poor guy. I really think it wasn't a drop. If you think about it, there was these are all exposed. So if a dangling power connector, a dangling one, sort of hit one of these, it would immediately blow the LED. And then you could see how it would just flick over and hit here, and this is one of the chips that blew. I'll just see where they are on the board. Yeah, it's these two chips here, blue. This one was fine. These are the same chip. That's the same chip. That's the same chip as this. And both of these are damaged. So it kind of, it's kind of telling that it probably was something like that. Ah, and which one is it? Because it's an indication of how rare these are, is that you can track them. Pictures of them are, you know, you find them on the... But look, if we go to the Wikipedia, Acorn System 1, and there's a Wikipedia entry, and here is... There's the thing, I should probably save this. Well, you know what? I'm going to actually save this image because you'll see why in a minute. There's some damage has happened here. To that logo from this photograph, but if you look at that, you can see that it's exactly the same model. Now we have a look at the RS. So I could actually upload a better picture than this, because that looks, look at the state of that. It is that one, and you can see the horrible connector that they put on. This horrible connector here, right? And which wasn't the original. I'm actually curious, are they literally the same chips? Yeah, they look like, it looks like there was no attempt to replace. Yeah, it looks like there was no attempt to replace any of these, so I have the same chips that we can see in the picture here. And what's not clear as well is that this display was attached to this metal plate by these horrible rusting brackets that were glued on. You know, quite unpleasant thing, so I had to remove that as well. And there you go. So the point is that this Acorn System 1 is this Acorn System 1. This board is the same thing. These two, that's the top, and that's the inner one on there. You can see a bit of a mess on this connector here. This is actually a voltage regulator, and this had been replaced at some point, because I think it had broken, but whoever did the replacement just unclipped the previous one and then soldered this one over the top rather than going through the holes, which you know, admittedly probably saved damage to the PCB. That's still in there. And I think I've got these original RAM chips, but they're in my Acorn Atom, because the Atom had a I bought an Acorn Atom as well, and that had a damaged RAM chip, which I've managed to source. But in order to get that to run, I use the 2114s. These are 1K 4-bit RAM chips. So these two together make 1K of RAM. But I do have those. They're in my Acorn Atom at the moment. You can see as well, it came with two INS 8145. Oh, well, 8154Ns. This would have been bought separately. You can see it's a different batch. This is not necessary for the thing to run locally, but what it does is it provides, on this connector you can get access to all the input output pins, so it allows it to be a microcontroller, So the whole thing together is able to be programmed. It's like a self-contained microcontroller that you can program without needing to use a computer. You know, now you can get the equivalent of all of this pretty much in one chip, and you have been able to for quite some time. But there you go. And those are quite difficult to find. These INS 8154s are difficult to source. So they've got two, and they both seem to be working. So that's actually quite nice. And there we go. That's the story. But you can tell they've got to be rare, right? If I bought one off eBay and it turned out to be the one on the wiki, which I didn't know until I got it. Let's have a look on eBay. eBay, have we got any more? There's an Acorn, right, so on Acorn Watch there is an Acorn Atom for sale. This Acorn Atom, £499. That is more expensive than the one that I got. But, you know, here it is. The case is in pretty good condition, except for the discoloration on the top. And that was from heat from the, you know, the voltage regulator in there. So this has probably seen quite a bit of use. You might be able to get rid of that discoloration by various tricks that retro gamers use to restore the cases. That looks quite nice though, other than that. And there it is. There it is again. It's like dangling wires soldered in. Yeah, there was very... yeah. We can just see me. Yes, you're right. Thank you. I was... Alright. So let's see if I can... I need... Yeah, so I was looking at this Acorn Atom here. Oh! So you missed everything I showed about the Acorn System 1. Oh, here... Damn, you couldn't see what I was looking at. That's bad. I need to have a kind of alarm bell that we can... that can be used, you know. But anyway, that was it. These are those INS 154s. That's the voltage regulator I was just talking about. Those are the two RAM chips. And then this is the upper board. You know, and you can see there's the display, there's the horrible rusty thing that I put on there, and here are all the chips, and there you go. All right, it needs to be. I need to set up a thing that people can grab my attention with with a warning sound. I'll have to figure out a way of doing that. Anyway, there we go. And then I was looking at the Acorn Atom. £499 is the only one. I think it's probably find it's the only Acorn Atom for sale anywhere. They are also really difficult to find. Acorn System 1, nothing. Nada. Not going to find one. Acorn BBC Micros, they're quite easy to get. I have some BBC Micros. So the Acorn Atom's something else I'm looking forward to getting out. Make Hal read chat. Yes, I think I should. I'll have to look into that, and then I can fix that problem. So there we go. Anyway, let's get back to... So that's something to look forward to. But meanwhile, I'm going to get back to development on Phi. How are we doing on the chat? That's fine. If I go to cam only, I think one thing I need to do is put on properties, deactivate when not showing. This is important, because then when I switch back to this, I should be able to do the video capture device. Deactivate, activate. There we go. Aha! That worked. Let's see. So can I switch between these two? Yeah, that's not really very well thought through, is it? I wonder if I can cam only. I don't know. It could be up to a couple of weeks because I couldn't get them from normal quick sources because those ripple counters are difficult to get hold of, it seems. Just put that back. Oh, other news on repairs. Ooh, another vintage thing I'm going to show you, but once I fix the camera, because everything's gone blank, hasn't it? Add a video capture device. Alright, so if I go scene, with video capture device 3, there must be a way I can move the video capture device. We add existing device number 3. Okay, and then when I switched it, that's good. Yes, that's good. So I can switch. Yeah, great. Look, I'm beginning to cook with gas or something. This has also been repaired. This works again. I had started as a project to try and that would be good, but the problem is we need people with Acorn System 1s. This thing is an Echo Plus PDS 8000. It's a beautiful thing. I bought it in the 80s, mid to late 80s. This was my favourite pedal. 8-second delay, up to 8 seconds. 8 seconds, pretty damn long delay. But you can. It also has a infinite mode, so that you can. It just sits and it will repeat stably the what's recorded. So in fact, you can use this as a loop station in effect, up to 8 seconds, which was a lot in the 80s. And it can also sample and be triggered. There's a trigger input, so you could use it as a kind of a little sampler as well. I'm looking forward to, maybe I'll stream some stuff with this because it's really good. What was wrong with it? Well, one thing that was wrong was there was a capacitor on the board. It was electrolytic. It had shorted, it had shorted the other side of the internal voltage regulator, but in a way that didn't damage anything. But I had to replace it, and then it still didn't work, and I was like, oh. And so I said, okay, you know what I need to do? I'd like to get a circuit diagram of this. So I started tracing the circuit diagram. I don't know if I'll ever finish that now, because this now works. But the funny thing was, as I was looking at this, and I started trying to trace some of the, can I check to see if the chips are working or whatever, and I found the problem, and it was a stupid thing. I had replaced all of the chips. One of the chips had a bent lead. I mean, that's just such a newbie thing. But it was weird because it bent, but not in a way that was obvious under the thing. And it's like I replaced that, and then it worked. little thing though is these can be really confusing when you're repairing them, because you'll plug them in and then you'll try to press this to see this light, LED light up, to tell you that this part is working. And the problem is, if you put it on at 8 seconds, it takes 8 seconds for it to reset, because it's working through its memory. I think you can speed that up if you turn this knob, right? You know, to make the delay shorter. If you switch this switch, it has to reset. And so you're there and you're going, it doesn't work. I press this and I see it's little blinking there, little, and I swear I've been through this before. But in fact, you've got to be patient with it. So just put it on, maybe put it on the fast setting, but whatever. Leave it for 8 seconds before you start using it, and then you'll probably be all right. So yeah, it's a lovely thing. And it was battery powered as well. You can put I don't know how long the battery lasts, probably not very long at all. Wonderful. So very happy that is working. Anyway, right. So maybe I'll connect that up to the Acorn System 1. Why not? You could store 8 seconds of program in there. They don't build them like that anymore. Well, that's one reason to get the circuit diagram. I'd like to be able to build, I was thinking, build replicas of it. It's awesome pedal, it just is. And it sounds good, even though it's not necessarily the highest Phi. It actually sounds good. And you can twiddle the knob, so it's unlike the problem with the digital pedals these days is they always have latency and the controls are not friendly. In this one you can record your 8 second or a thing, right? And you can't, one thing you can't do is indicate the beginning and end of the sample. So you have to synchronize it to the time that you've set for the delay. Really good for getting your timing. You're better than using a metronome for developing your sense of timing. So that's one thing I developed my sense of timing for music from, was with that pedal, right? But once you've got the thing looping, you can then change the delay time and it changes the pitch of what was recorded immediately. So you can actually record on it and change the pitch of what you've recorded, right? And then play along with the changed pitch. We've changed the time as well, but you can play along with it. You can then actually overlay a new sound over the top after it's pitch shifted, right? So if you're talking about being creative with that kind of thing, it's got less tech, it's less advanced tech, but it's more creative. You can't do that with modern pedals, right? It's like the same old flipping story. It's like what's the boot up time of the Acorn System 1? It's literally instant. Okay, what about your PC? So I was thinking one thing that might be a good topic, right, to cover is all the ways in which a retro PC is better than the stuff you get today. The features. So we could do that. The features of the Acorn System 1. You know, like it's all self-contained. It's small. You don't need to plug it into a monitor or a TV. You know, these are advantages. Has an intuitive user interface. Yes, I joke not. You want to read and modify memory, you press the M button, you type in the address you want, you press M again, and then you have an up and down that allows you to move through memory. You can see the memory, and you can just type if you want to change it. And this will be very interesting because the point here is how the user interface of the Acorn System 1 is in some way superior to interfaces of things that we have today, even though it's from 1979 and is running on a 1 megahertz 6502 and only has 1K of RAM. The interface of the Acorn System 1 is a work of it's beautiful, because let's say you hit reset, you press M, and it remembers the RAS memory address that you used. I tell you, that's more advanced than a lot of software that we get today, where it can't remember what the damn path was that you just used. So when you go to a menu again, you have to go and click, and we're going back to where we were before because the software wouldn't remember it. There was some very fundamental user interface sort of design lessons that I learned from the Acorn System 1. That was one of them. You know, so when you want to go, you press the G button. So you press G, you type in your address, and you press G again, and then it goes. That's how you run execution of code. Great. You hit reset. Guess what? You press G. It's remembered that execution address. So if you want to rerun a program, you just do reset, go, go. Reset, go, go. You see how beautiful that design is? It's fast. Reset, go. Because it's go and go, same button. You can hit it twice very nicely. And you can see Villa in Blake 7 do that in the final series. I think it's season 4 of Blake 7. In one of the episodes, he has to start up the computer system that they had, which was called Slave. Very much smaller than the wonderful thing they had in the bigger ship, the Liberator. Final season, they seem to lose their budget or something, I don't know. But anyway, Slave, which was these 2 rotating domes, and in the middle of the 2 rotating domes is an Acorn System 1. This was a series from the 80s. And so basically they had the Acorn System 1 driving stepper motors that were making these things spin for the effect. And Villa, one of the characters, goes there, and you see him hit reset and press the G button twice. Doop, doop, doop. Off it goes. You know, that's really cool. I just like I like the thought that every time they had to film you know, Blake 7 in the final season, someone was there with a cassette recorder. Okay, right, just starting up Slave. They would have had to plug in. Probably there was a tape recorder around the back, you know, and what you have to press reset and the load button and type in the address where it was going to be loaded. You know, and then hit load again. And then press play on the cassette. Let it load up, you know, and then it's like, oh, good to go. Test it, hit reset, go twice. Somebody was doing that on the, yeah, to make that work. Because when they turn it off, it lost its program. Be lovely to get a copy of that. If someone had that would be amazing. But they're you know, it's one of those things that now, how would we make that? I mean, you know, if Microsoft, or what would be Microsoft's version of the Acorn System 1 user interface? I dread to think. You just need to look at Skype and give you a clue. Entering hex. Yes, that's the point. Sometimes you want to. Sometimes you want to enter in hex. I know if I needed to make a hex editor, I would make that hex editor like the Acorn System flipping 1. And Visual Studio won't remember the address you have. I think it doesn't. I mean, it's like nuts. Remember every time. Have it remember the last thing that somebody did. I mean, even Unreal doesn't do it in their flipping blueprints. Well, this drives me nuts. It's such a simple, stupid thing to do. It's like when you're making blueprints, you do a right click, you get this menu. The menu appears and gives you things. They're all the things in context, you know. I don't care about the context. I don't care about 99% of the damn things. The one I'm most likely to care about is the last one that I used. And, you know, actually we're in 2021 now. Maybe we can actually have a list of the top 10 or 5. The probability is, if you list the last ones that we used, the last 10 different types that we used in the drop-down menu, you probably got one that the person wants, and then they can just click on it with their mouse, and you can learn that from the user interface of a damn microcontroller that was made in 1979. Why don't we learn? But this is a hobby horse of mine. You know, when there's like something that would be really, really simple to implement and just would make things go so much better. But we don't. We're not orientated in that way of thinking. But back in the day, when you had to make you had constraints, more constraints, you seem to end up with a better UI. Counterintuitive, isn't it? But it's because it's that thing I said, you know, when I said everything is possible if you just have enough discipline. The only thing limiting you is discipline. And so it turns out that if you have less to work with, you can probably be more creative. You know? JB was pissed why computers wouldn't tell you why it couldn't find a file in a path. Yes, I know, I saw that. It was in Comet. That's absolutely right. Come on, people. Can we please drag our user interfaces back to the 1980s? Thank you. Because they were better in the 1980s. Or if you want to see, go back even further, everybody should go and watch that video. It's on YouTube. It's called The Mother of All Demos. Check that out. The Mother of All Demos. And it is the earliest demo of interactive visual software interfaces. A vision for how computers could be in the future. And the weird thing is that some of the things that are demonstrated in that demo would now be considered to be innovative. And this demo's in the 60s. We've lost our way. Boy, have we lost our way. Anyway. You're so lost, because you're going to look at that demo and go, well, that's amazing for the 1960s, and it preempts a whole bunch of stuff. There is a mouse. There is a mouse. There is a left-hand keypad, just like I have here. This is a game pad. But you will see that's the setup. It had on his right hand a mouse with multiple buttons. Thank you very much. Multi-buttons. Admittedly, this one has actually got these two buttons here, but the funny thing is they never make these so that you want to use them. You know, it's really weird. You look at there, it's like nice chunky buttons. You get a sense of, you know, they're deliberate anyway, you'll get the point if you look at it. The left-hand thing had other buttons in there. It had a keyboard in the center. It's actually funny because I end up with the same setup, right? And this thinking is very valid because it means that when you are working with a keyboard, that's why I like to have this setup. I can get into a mode where my right hand is on the mouse and I don't have to take it off the mouse. And my left hand is on the keypad, and between the two I can do operations that do not require typing without needing to move my hands. This guy who did this demo figured that out in the 60s. But what do we have today? Well, problem is we don't have any standardization for a start, so I end up having to reconfigure the stuff, you know, and that's a pain. And also, there can be applications that this doesn't work with, and or who knows what. This, I'll just remove this. Oh, jeez. But anyway, what we find. That's the problem as well, is then you use a piece of software and then you've got to have to figure out how to map this to the particular software packages that you're using, and so a lot of the time we can't be bothered. But if I start getting into the one particular, say I'm in Visual Studio, I'm doing one particular thing for a length of time, I will configure this so that I can get into that mode of operation where I'm just cruising along, you know. But what we have today is very common that you end up needing to take your hand off the mouse all the time, and you're moving your hand from the mouse to the keyboard. You know, especially if you have something like Control backspace, or, you know, it's like, I suppose you can do it with your right hand, but you're moving your right hand all the way across the keyboard. It's like, it drives me nuts. It's like, you know, it's like Control F12, okay, you know, or Control F5 with one hand. It's you. I suppose you can do it, but it's like, you know, yeah. So you end up moving your hand in practice backwards and forwards from the mouse back to the keyboard, mouse keyboard, mouse keyboard. Really, whatever. And a headset. Yes, that's right. And a headset. It's absolutely absolutely amazing. But I'm not going to go there now. We need to drag computing back to the 1960s and start again. And part of the problem is that computing was viewed as a commodity instead of as an art form, like life. We treat life as a commodity instead of a life form, instead of life. Do you know what I'm saying? It's like life is something that's meant to be lived, not done. We don't do life, we live life. But the things that we make, they need to be made with that same philosophy. They need to be lived, not delivered. And so the software artifacts that we create, the huge amount of them, they disappear, never to appear again. Software that becomes obsolete. And you know, or you just, how much software is out there that was written that has been thrown away? It's disgusting. Then there are some areas where it's been written and it continues. And that's usually in the Linux domain, Unix domain, right? Where things like, it's one reason I love Emacs, is Emacs is basically the same as it was 20 years ago. That's very comforting. What about Visual Studio? Change the keyboard mapping of it for every five seconds. We change the menus every 5 seconds. You just don't know where you are anymore. We write software like we make stuff these days. It's with built-in obsolescence, and it doesn't last. And software should last. We should make things that last. And the way to make things that have a long-term meaning is that we make things not because they're a commodity, but because the act of actually making them is something that has value in and of itself, just like art does. If we can have tunes, that says music that survive the test of time, like the classical music of Mozart or Bach, survived the test of time. Well, damn it, can't we have software that survives the test of time? And as we, as human beings, become increasingly dependent upon software, is this not actually essential? That we can create things that stand the test of time, not keep obsoleting them, or figuring out clever and smart ways that we can make stuff obsolete to replace it by something else, just so that we can say we've got something more to do, or some more profit to make, or some more whatever. How are we going round and round in circles, you know, in terms of our solutions, and people get bored of this solution and they want to have another solution. I bet you were going round in circles, you know. One thing I joke about is the problem of widescreen. I'm ranting. I'm on a rant rage here. I think it's because I didn't stream enough. Then I have to get the rants out. But you know, it's like we had 4:5 ratio screens, right? It's like a good old sort of TV sort of ratios, right? That's actually they're really quite good as monitors for actual work that we do on computers, unless you want to watch a movie. And if you want to watch a movie, then you have this banding. But so what? Who the hell cares? And anyway, watching movies is only a very small part of what we use computers for. Like playing video games, there's actually an argument that you could do better by having a less oblong aspect ratio, so that you've got a bit of a sense of up and down. I mean, is gaming of the future going to be a screen like this that literally is a letterbox? It's very wide. You know, let's have 5,000 pixels wide and like just 1080 high. I mean, it's insane. But that's the way it goes. Wide. Let's make it even wider. Let's have 3 people who get 3 super wide monitors and put them side by side, and it's all like, wow, this is amazing. But it's like you can also look at it as just a very big screen that's been cut off on the top and the bottom, and then you end up with that horrible problem that you're on the internet on your super wide screen. And because I think things have changed a little bit, but because when it came to content that needs to be read, we of course go back to A4, you end up with this huge thing like this, and you're on a website where you could cry. The A4 doesn't fit very well, you know. So you end up you want a whole web page on your thing, and it's like this little thing like this on a huge screen, and you're scrolling up and down. Have you been there? It's just like an utter joke. That's why I have a square screen. The one that you see here, you might notice this guy, it's square. It's because it is actually square. It's a square. It's 1-to-1 aspect ratio. It's an ISO thing. ISO. They made these. I got it 4 or 5 years ago. I really wanted it when they had it. I'm sure they don't make them anymore. For a brief period, it was possible to get them. Maybe you tell me if you can still get them. I wanted it and I managed to get one, and I'm really glad I do. It's my favourite monitor. It's 1920 by 1920. And if anything, I'm really glad I got it as a fracking protest against this nonsense, because what will happen one day, if it hasn't already, is that, you know, after having created super wide monitors, they're going to invent the super wide tall monitor. That's the monitor that is super wide, because we've already got that, but the new gimmick on top of that is it's going to be tall. So you end up with a wide tall monitor, and you end up back where we started. But no doubt that will happen when, having actually reduced the height of screens for everybody, marketing decides that we can sort of sell the idea of having tall screens again. You search for a light text editor and it was built on Lua. Right. I think I got the ranting out. It's like, there we are. Well, you have to rant sometimes. And I care about this, and you know, I care about stuff. I haven't been making software for over 40 years for not to care. And I really do care. And I think we need to fix some things. Unfortunately, there are too many things to fix, and I only have one life. Right now, what am I trying to fix? The entire of software engineering with the Phi programming language. There we go, just a small ask. HAL Open Phi project.
Opening Phi project.
What makes a square monitor better is just that you don't have... You can think of a square monitor. Well, the first thing is it's 1920 high. Now, if you've got a 4K screen, you can get a little more than 1920 high, or you can get 1920 high, or whatever, right? But it's going to be small. If you actually want to keep the aspect ratio of an HD aspect ratio, right, and get 1920 high and have any reasonable amount of size, it ends up being really wide. The monitor becomes huge. It becomes like a TV. And that is an option. You could go for, you know, basically a 4K TV. But the first thing is that those were not really that much of an option 5 years ago. So I might go that way next time. But what I find is that if I use a 4K screen, it's tiny. Everything's tiny. It's too small unless I could get it really blown up. So this screen, it's not very wide, right? It's very practical. But I have a full height of 1920. That, for me, that this area here is 1920 high. And so what I would do often without a square monitor is I would take a normal monitor and I'd rotate it so it's vertical. But I don't know if you've done that, but if you do that, it's a bit crazy because they're so tall and they're not very wide. You know, if you're in HD land, you end up with a screen that's only 1080 pixels across. So now you can list your source code very nicely, but it's a little bit cramped, but it's still better. So when I'm working in a studio, I always, you know, people who've colleagues will vouch for this, ex-colleagues will vouch for it, it's like I'm always there with a monitor turned up vertical. I have one vertical, one horizontal, just so that I can view a whole bunch of things. So I view my square one as being one of those, but wider, and I like it. So anyway, right. We're on here, and Hal, run Nugget window.
Running Nugget window server.
That's right, we've got that there. That's cool. And then Hal, run. Yep, so this is where it was left off last time. My Phi project. So I've got a moving cube. It's moving very slowly, but speed's not the important thing at the moment. And it's a moving cube using Phi. Here's the Phi program. On begin, clear graphics, and when the coordinates of the cube change, then you update the position of the cube. And when the graphics are cleared, so you say on begin clear graphics, and on change graphics cleared. I want to improve in the language the ways of presenting this, but basically a side effect of clear graphics is that the global variable graphics cleared becomes set. When that is set, then it makes the cube. So this way it's able to clear the graphics first and then it makes the cube. The principle behind Phi is everything is asynchronous, so therefore everything is in effect running on a dependency graph. Because the language is represented as a dependency graph rather than a sequence of instructions that need to be executed in order, you are in fact expressing intent directly, and there's no need to sort of have any kind of special code for figuring out, or try to do a static analysis to figure out the dependency graph. The code written in Phi is a dependency graph already. You are writing in a dependency graph immediately. This means the static analysis of a program written in Phi should be a lot easier because it's already a dependency graph. So this is a very early attempt at doing animation with Phi. And there are a few things now, this is working, that I want to sort of improve upon. One is that the rules for updating the cube position, basically update cube position is an internal function which communicates, built-in function at the moment, which communicates with the viewer. The thing you can see up here is the viewer, which is one part of the screen here. I wonder, I could make this bigger, couldn't I? Should I? Because I'm not using this area. Oh no, I will use this area of the screen for other stuff. That's right. There's a reason for this, because they're for debugging. So the graphics capability here is done using Nugget Window, which was another project. It's written in Unreal, also, so that this has now changed. It was written in Unreal also as an exercise in me learning Unreal. There we go. And it listens over the network for instructions that allow the creation and movement of objects in the scene. Update cube position is a built-in function. I just realized it's called cube position, and it shouldn't need to be saying cube. I'll fix that, because it should just update position, and you give the name of the object you want to update. So when the graphics are cleared, it makes a cube, and when the position of the cube changes, it should send a request to the viewer to move the cube. The cube is living on the viewer, which is a completely separate program to the Phi program, and is communicating over the network. So the problem here, so I'm going to just refactor this little test case to both the language and also the implementation. That's going to be the thing I'm going to look at for a minute here. So one problem we have is that there's no way currently to express nicely that I want to update the cube position if any of cube pos X, Y or Z changes. I think what I want to do is put in a new language feature. This is the second thing I will do, where I can just say cube position X, comma, cube position Y, comma, cube position Z. And so then if any of those change, it's a list where if any of the things which are listed changes, it executes the action update cube position. So that will be a good thing to work on. The other thing is, which is a small thing, I want to change this so it doesn't say update cube position. It shouldn't need to. It's update position, and then you give the name of the thing that you want to. The name is taken here as just the identifier that I use in the language, and that's literally passed to the viewer. So the viewer will know the cube as being called cube. If I try running this, I'd expect to get an error, which is unknown function update position. So we're going to look at the built-in function. So there is, for the built-in functions, a update cube position. And I'm just going to get rid of the word cube. It's unnecessary. Reflection for being able to call functions by name is simply done here by a map, where I map the name to the function. Update position to update cube position. And if I try running this, what we should get is, well, undeclared identifier. And that's because I removed the wrong thing. Update position, let's try that. And I think we're running again and test to make sure that it's working. So there's a very small, simple refactor. Doesn't change the functionality, but it's now, that's better. Update position cube. Okay. Next thing I'm going to try is to literally be able to say this Z. A further step later would be able to say cube pos, and then any change to the children would of pos. Of course, there's how to implement that, and I think a way I would implement, yeah, that's an interesting question, how to do that one. If I said just cube pos, does it would need to have a rule or a way of knowing if pos changed, if any of the children did. That seems to be a bit complicated, so I'm going to reserve that for later. It doesn't change the proof of concept in the language. So, I mean, I might be able to do something like cube pos star, might make sense, but I'm going to leave it like that for now. So if I HAL compile, yes, HAL compile. Oh, I mean HAL run. I sprayed some WD-40 into HAL's microphone where it's plugged in. Maybe that will help. Sometimes it's having trouble. So if I do that, yeah, it's interesting because we've got stuff left on the stack. It parsed it okay, which I find interesting. It did, yeah, it succeeded in parsing. So I'm going to have a look at the language definition and just understand what happened there. If we're looking at commas. An expression, comma, expression. I think the problem there is that I added this in, but it doesn't actually process it. I'm going to look at, and then because it doesn't do anything with it, it gets left on the stack. WD-40, amazing thing. So a bit of WD-40 to fix Hal. Hello, Hal. Hello, Hal.
Hello, Dino.
Okay. I think Hal wasn't impressed with the WD-40 thing, you know. Okay. So let's have a look for comma. Yeah, this is not really doing anything. I'm just going to confirm that by putting a breakpoint in here, seeing if it arrives. It does at that breakpoint. And just to help understand. Ooh. Hal thought I said something there. Oh, let's go cd ////, and then while it's running, it produces log files, and one of them is the estack state. As you can see, this is showing the state of the stack, the expression stack. I think the language file that we have is testfy. I'm just going to comment that out, like so, and try running. And it still has a comma in there. So where is there? Where does it see a comma? Oh, I took out the wrong one. Sorry, I meant to do this. I'm expecting I'm expecting it not to hit that breakpoint if I remove the comma. It's just a reality check on there. Yeah, that. It's not updating the cube because I took out the rule. So that actually makes sense. But that verifies that this rule is being processed here, and as we can see, it's doing nothing. Expression comma and the file. Actually, let me pin that. There we go. Oh, it's for a pinned. Good. So when we're looking at this, we see this comma, with operation comma is a parsing thing that's found, but expression comma and expression comma is this one. So what does it mean to have a comma? I think I need to look at the parsing of a change. So onChange is defined as a change keyword followed by a watch, followed by an expression. The watch is an expression. which kind of makes sense. Oh.
Hello, Dino.
Shh. An expression can be a list of. I need to review this. I think the way that I was doing the commas, it doesn't make quite sense. In the C programming language, you can create an expression from two expressions by putting a comma in between them, in which case it executes all of the expressions in order and then just returns the value of the last expression. This is a different thing here, really. I think I'm going to comment that out because I think that I need to have a watch as being defined as a list of expressions, and then on change is a watch followed by an expression, but what I need is a watch followed by action or actions. We could actually say watches followed by actions. And actions is a list of expressions, and watches is also a list of expressions. So what I'm going to do is I start off by commenting that out. Now I can do HAL compile. See, now I don't need to move my hands while I do this because I've also this no longer exists. So, as a comma, I'm just going to get rid of it. So I wasn't really using it anyway at this moment. Where's my delete? There it is. Okay. HAL compile. And if it succeeded, so wow, yeah, because nothing was using it. Amazing. HAL run. Okay, it doesn't parse it anymore because I've taken out its ability to recognize commas, but I still have commas in my test file, which is here. Just to be thorough then, I'm going to comment out HAL run. Yeah, that was working. It's not updating the queue because the rule isn't working anymore. So let's have a look at the language file, and what I'm going to do is just continue a refactoring of this so that on change construct is a change followed by watches followed by expressions, and I need to be able to say what a watch is, which was this, is now watches is an expression list in effect. Well, let's see. I can just say that it's an expression list since I already have that. Looks like I did this and I changed my mind. So I had it that way before. Watch is an expression list, and then we can also have expressions. Is also an expression list. Let's see what happens. Howl compile. Howl compile. Howl. Haha. Howl. Hello, Howl.
Hello, Dino.
Howl compile. Watch context is not a member. Right. Because now this is watches context. Visit watches. Howl compile. And that is now working. Let's go back to test file. I've still got, right, just check that I haven't broken anything. Howl run. Howl run. Howl run. Oh, you're really annoying me. Howl run. It's all to do with the tone of voice. Okay, that's fine. I think actually what I'd like to do is have new instruction, new command. How stop debugging. How stop debugging. Seriously. Oh, it's because I'm not in there. How stop debugging. Less than successful. It did actually recognize it. Control F5. Debug. Stop. Oh, Shift F5. I'm the wrong one. Do 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 do. How stop debugging? How stop debugging? So why does that not work? So stop debugging is this, right? Damn. It was the wrong one. Howl run. Howl run. Howl run. Howl run. Hello, Howl. Hello, Howl. Howl's gone into a sulk. Are we going to work now? Howl, run. Howl, stop debugging. Alright. So, okay. So when we visit the watches, then we can add, there's this add watch. And what does that do? Add watch. Get current watches, push back, expression. That's kind of interesting. I'm trying to understand what I was doing there. Haven't looked at this code in a while. Get current watches, push back, get expression. Right, I want to understand what this is about. Watch current and watch previous. Yeah, I don't know. You can watch current. Oh, because yes, I have to have that kind of like double buffered. So it's just, I've got to refresh my memory on this. Go current watches, XCOM is a list. Graphics cleared. Right, that's the that's this one, on change graphics cleared. So it's looking at that watch. Yeah, it's a little ropey, but that's fine. It's basically allocating space for the watch. That I could just say add watch and it just will pull it off the expression stack, as we will see. So when we do this add watch, it's saying expression construction is constructing an expression. And it clears. When it's finished. So what I need to do is extend this so that it can work with a list of expressions. So I think before I do that, let's just change, we put this back, or if I copy it, and I'm only going to test the X position. This should just work as before. Hal run. Hal run. Yeah, it's not moving. Oh, because I changed the Y, not the X. Fair enough. Hal, stop debugging. Hal, stop debugging. Hello, Hal.
Hello, Dino.
That's weird. Hal, stop debugging. So the... oh... yeah, so there's a little problem with the stop debugging. It wasn't, I need to have Visual Studio selected. Hal, stop debugging. Right. So what I need to do is change my example code here so that it's when Y changes. Hal, run. Okay, cool. So that is still working. Now we're going to try a thing cube.pos.y. I'm going to say it twice. Well, why not? It just doesn't matter. Just say right, cube y, cube pos x, and then get it so that this works. It's going to generate an error probably. Yeah, items left on stack. I'm just curious as to why it left 2 items on the stack. All right, well, we come back to here, and there was add watch, which was called from here, which says visit watches. That's when it's parsing the watches. Parsing the watches. And we'll see how many times. Seems to have done it 3 times. So we have the expression was dot Let's make sure that that log is working. Okay. And I'll put this breakpoint in. Ah, yeah, because there are a number of watches before it gets to that one. Yeah, okay, let's try that again. So I didn't reset the thing. The behavior was different. Yeah, I get it all in one go, which is kind of weird. The graphics cleared. Dot cube pos. Right, to help me debug that, I think what I need to do is just comment out everything to simplify and just work on the particular syntax I'm looking for, where I can just say on change a comma b comma c, or let's do a comma b, c equal 2, and see how that gets interpreted. Because visit watches is called once, twice. We can see what's going on a bit more easily. Items left on the stack, A and B, because it added. All right, and what I'll do is just put only one of these and see what happens there. So it calls it once, twice, so it still calls it twice. Let's see if I can understand. Context. What's in expression construction? We have nothing right now. Oh no, there's one. Because we visited the children, and that caused things to get constructed. So it'd be good to see what happened to the stack at that point. Just to... It's not evaluating the stack at this point, it's parsing it, evaluating the expression, it's parsing the expression. Get expression. Well, we have a list, it just returns the list. The list has one element in it, and it's the identifier A. So currently there is no elements in this. The one that gets I need to know which one that populates it with. Oh well, yeah, it's just creating the expression, right? Yes, of course. Or rather, assembling the expression. And then it's finished here, assembling the expression. It adds the... Okay, right, so what I'll do is put here... Sorry, I'm just remembering how this works. So, fine. When I get this, I have the expression. The expression is one element in it, which is the identifier A. The second time this comes through, at this point, we have frame count. So why do we have frame count? Ah, it was one I hadn't commented. That was throwing me off. Okay, right. Back. That's sending me on a wild goose chase. There's only one call for this, which is absolutely correct. Now, if I go here and I say on change A, B, what happens? Items left on stack. Let's put the breakpoint back in here, and we go again. Again, it only visits it once. So what? Yeah. Okay. So when we arrive here and it's adding the watch, it's probably going to have an expression with two elements in it. Yeah, size 2, that's it. And what's in it is A and B. So yes, the list automatically exists here. We have a number of expressions. No, we don't have a number of expressions. We've got two. We should have two expressions, but it's actually turned into one expression, just A, B. Right, and what I need to know is what happens if this expressions, if I do that, for example, what happens? When we get here, we've got then probably 6. That's correct, because what we have is 2 expressions, one after the other. So what I actually need to do is add a watch for each of the expressions separately. And I think the answer to this is to look at the language definition. And when I looked at the watches, which is on change, watches, what's the definition of watches? Is an expression list. It becomes easier if I call it a watch list. I think it'll just be, it'll be easier to parse it. So we can do here, watch list, expression, comma, expression. But because it's called watch list, I will then have a thing here which is visit watch list. Let's see if that works. So I'm going to run that, and you can do your watch list. I'm going to check, what do I have? 6, and it's still all there. Yeah, that didn't change anything. Yeah. And I need to break it down into yes. Thinking about where this needs to happen. I made the thing so that I could check if any expression changes. So I could say if A plus B changes. But I think I want to... Oh, that's another issue. So yeah, unless I Oh, right. I think I know what I need to do. The problem is I create a watch list as an expression followed by expression, but so it's actually getting processed. I need to sort of be able to take each expression and deal with it separately, differently when it's a watch list. So maybe what I need to do is say, well, first of all, I think that's irrelevant what I did there. So let's put this back. I said X. Oh, no, actually, maybe not. I'll keep it as. Oh, maybe I can do it like this. So watches are an expression. I call it a W expression, where a W expression is an expression. So basically, by doing that, I can use a W expression in my thing. So this then becomes, put this back to watches, like so. See if this works. Not watched, watches. Okay, and when I look at this, I see that I have 6 items in my list, and this is going to change the. I'm going to change the way this works a little bit. So the definition is that it's not. I won't be allowed to do that. What I have to have is on change is a list of identifiers only. Well, in that case, I can also go and say that a W expression isn't an expression anymore, but is an identifier. Don't I have that? Oh, right. Like so. Unhandled byte value for type, integer for plus. Because I didn't save that for some reason. Let's try again. No. So now when we adding the watch, the list that we have is empty. It's empty because I'm not processing the new W expression. Virtual antler CPP any visit W expression phi parser W expression context star context override. So see if that compiles. No. Syntax error. Yes. must return a value. Okay. So let's make sure that gets called. And there it is. This gets called as it processes visit watches. So in this visit children. We should see that if I put a breakpoint there as well. So it's like, yeah, it goes to that first, then it comes to the... So that is now called on each one of the expressions, where it should be an identifier. And I need to see when I was doing the visit X construction, there will be an identifier add thing. It's like this add identifier would actually be what we would need to add here. So if I do expression construction add identifier S, where did S come from? Get text. So the parser will see this. I add an identifier, and it should hit that breakpoint, and I should see it in the expression construction. So okay, so blah 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 blah, and here we see in there we have size of 2. We have A and B, which is fine, except they are both So what I could do is create an expression, which I am, as a list of identifiers, which is absolutely fine. That's what that expression will be. And the expression stack, yeah, but do I even need to? But yeah, why not? We can use the expression stack. It'll be a list of watches that need to be processed. And okay, I'm curious if this will... Well, we can test it like this. On begin, A equal 1. On change A, B equal 2. And that actually worked. So that's actually cool. That little thing changed without... That worked without any change. This is printing out more stuff because there's... it must be updating the frames. I don't know why it stays on the stack, but I'll worry about that in a minute. On change B, C equal 3. One to A, 2 to B, 3 to C. That's working fine. But if I go and say on change A or B, that's what that means. If either A or B changes, assign 3 to C, then I'm left with items on the stack. So I need to do the watch expression when the watch is executed. Evaluate current watches. This goes through all of the watches and it Right. Let's just take a look what it gets into here. We're checking a watch. The watch has a variable A. So I'm simplifying. Before I could do a watch which was an expression. So I could say if the expression A times B changes, then execute this rule. But I'm removing that because I don't really see it adds anything. So in fact, when I evaluate, I don't need to evaluate this at all anymore. I'm just going to go actually if 0 here. There's no need for me to do an evaluation because I'm expecting it to be an identifier. So we're going to check that first of all. If val op oh, hang on, boom, 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 we get the top of the expression stack, and then we check to make sure that it's an identifier. If it's not an identifier, we're just going to create an error. Watch must be an identifier. And we'll just see what happens with that, if that just doesn't generate an error. And there was a problem. Okay, because something, stack top was called, back was called on an empty queue. Let's put a breakpoint in there. It doesn't even get there. Oh. No, it doesn't like that. It says the stack is empty. Oh, because of the evaluation. Get current watches. If the expressor has an identifier, expression stack has a 0 size, so in fact there's nothing, because I need to I only create the stack if I do an evaluation. So in fact, yeah, that's wrong. What I need to do is check to see X I don't know that reference actually. Oh, is that Arnold Schwarzenegger? And at some point he says it's empty in his accent. And that's what I would imagine. It's empty. I could just hear that being said in his voice. Oh. Okay. Oh, okay, all right. State current watches, and we look in the state, and what we see in the X, sorry. What's the type of X? Oh shoot, I shouldn't have auto. That's the problem, auto now. I don't know what this type is of this, but actually I can find out maybe if I do go to definition. Go to definition. Oh, it's just a vector of expression items. No, it's a vector of vectors. It's a vector of vectors. Yeah, it's nested vectors. Yeah, right. Well, right. So the first thing I should check is that x dot size should equal 1. If x dot size is not equal 1, then we should generate an error which is expected only one expression item. Then having got that, I can actually then check to make sure that x0 dot op, the watch must be an identifier. Let's just try running that and see what happens. Abort. Okay. And go la 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 la, and we on there, blah 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 blah. Right, so that worked, and now I know that I have this, and all I need to do is I can just go and say get current watch currently equal val, where it's actually x0. So by doing that, state get current watch. No, not correct. It's actually this one I need, because I need to read the value of it. So instead of val would be x0. I think, and frankly I'll just delete that. I think that variant should be good. Signed what, right? And what's the problem? Debug error. Retry. Identifier keys must have valid contexts. Oh, and boom. Interesting. Because I hit an interesting issue there, because that's all very well and good, but there's no identifier for that. Currently I don't support references to variables in other contexts directly, so therefore I know that yes, okay, so what I'm going to do is say expression item value equals this. So I'll make a copy of it. And then I'll need to just satisfy that check. I need to put, I've verified that it's an identifier. I need to set a context for it. So get current, I need to get the current context. Get current, yeah. So then I say, well, this variable, I need to give it the context, which is the current context, and then I use it. Let's see if this works. It does not like it. Okay, so let's see. We're going to do a retry. Must have well, I just did, didn't I? Interesting. I just thought I did it. What did I do wrong? Yes, it's a classic. You set up the new variable and then you forget to use it. Okay. Expected only one expression item. Interesting. Got an error there. Let's just right. Okay. Well, why? The size is 2. It's A and B. Yes, correct. Tell you what. Really know. Because the problem here is that I have more than one watch for the same rule. So get current There's an interesting question of how do I express the ORing of it. I mean, because I say, okay, I have 3 variables. If any of them change, I want to trigger the rule. But then I need to have a way to combine them into a value that uniquely indicates. You'll be like hashing it. That's no good. I don't want to do a hash. So it's actually possible that I can't do it that way. It's like how to, it seems like what I need to do is connect multiple watches to the same rule, and I can't do it. I shouldn't try to do it here. So this means that error is correct. Expected only one expression item, because when I evaluate the current watches, there should only be one identifier per watch, which means that it needs to be dealt with in the parsing stage, because when I do this, I add an identifier and then I add a watch. Alright, so I'll need to fix it here, but then when I'm looking at the add watch, I'm going, okay, current rule, add watch. Oh, I already have a way of adding multiple watches to the same rule, right? No. A rule contains only one watch currently. So I need to change the way it works so that there is a list of watches. Okay, all right. Let's just make sure that it's running and we get that error expected on one. All right, I'm going to have to refactor things so that I can have multiple watches. It's called add watch, but it just, I have a single watch index. And what I need to do is have multiple watches per rule. I mean, essentially this innocuous little thing here is the heart of the language. It's really short. It's like it contains watches and actions. Each rule can only have one action, but as it happens, it is okay because I need to reintroduce this. It only needs one action. Let's just check that that doesn't break anything. It only needs one action because an action can have a comma separated expression because it just executes all of the expressions which are separated by commas. That's right. And that's why it only needs one action. The original concept was the same with the watches. I only needed one watch because I was using expressions. But this turns out to be gnarly. So instead, I will add multiple watches. Sorry, you only need one watch because you could have multiple watches within one watch expression. But what I'm going to do is change it so that I just have a list of watches. This is fairly okay. So what I do is I'll do a vector of ints and call it watch indices. And that's enough just to get some errors that I'll just fix. So the first one is watch index equals, now this becomes push watch indices push back I. Right, let's try building again. Next one, the clear watch indices clear. Next, watch index. So this is this is for printing a rule. To convert a rule to a string. Well, that's weird. Oh, because it's an expression list to string the way that it was before. Okay, so what I'm doing is just commenting this out, and we can just do error not implemented if I try and do this debug function, because I'd rather just get this working first before I deal with that. Right, next one. Execute dependent rules. So this is the bit that checks to see if a rule is being triggered. Where's this? Oh, right. So if state get current watch x watch index op not equal operator none, this section needs to be rewritten. The first one is that we need to get we need to go through all of the watches in the list. So we can do this, blah blah blah, y equals state get watch current watch index get current rules x dot watch in indices. So we're going to go through all of the watches which are available. If get current watch current y dot op is not equal identifier, then that's an error case. Watch is not an identifier. It must be. Okay. If the state of, if the current watch y is not equal, so this is the check where it sees if a thing changed, and if there was a change it assigns get current watch and then it executes, so it executes rules which depend on the thing. All right. Yes. Yeah, I think that's fine. One of the issues though is that I don't want it to execute the rule multiple times. The rule is you execute the rule if any of these have changed. So Probably what I need to do is set a bool up here and call this changed and set this equal to false. Then it's going to iterate through these, and if this is executed, it's going to say changes equal true and immediately break. Then this I just need to check if changes, and then I like that. All right, so there I go. I think that is correct. It checks to see if there was a difference between them. It sets the current to the previous. Yeah, that makes sense for the next time when it wants to check if there's a change, because that's the rule. If I say on change A, I need to see if A changed. If it did, it sets the flag to true. It immediately breaks. There's no point in going through anymore. It will execute this only once on the rule. I think that is correct, but we shall see. I'll try it. Right, so errors first of all. Initializing cannot convert from int to, yeah, alright, so I think I can, right, changed equals true. This should be changed, changes. Alright, let's make it changed then. If changed, and then we go boom, and the next one, la la dee da dee da dee da, and expected only one expression item, so that was on this line. Evaluate current watches. Yes, that is actually because I didn't fix that yet. All I did was a refactoring to enable it to handle lists of watches per rule. If I want to do this test properly, let's go back to this test. On begin, set A equal to 1. When A changes, set B equal to 2. When B changes, set C equal to 3. We'll confirm that this works. Right, that doesn't work. Watch is not an identifier. Was this well, what was it? Come on, can you give me this expression? You know, can you evaluate this? No, you can't. You can't tell me what that is, can you, debugger? Why not? Because it's 2021. And debuggers, you know, there's a limit to what they can do. Actually, the problem is that it's because this is a function. Operator. Op equals. I don't know, but it's really annoying. I mean, you know, the debugger could have the intelligence to sort of cache that, I suppose. Maybe, maybe not. Maybe I'm asking too much. Anyway, it says it's an integer. Then what I'm going to do is it really it doesn't matter, because this comparison is comparing an operator. Yeah, because in fact the just to be clear, it's an integer. Oh dear. Oh god. Let's do this. Expression item E equals state blah 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 blah, and then over here we do E dot op, and we take E dot op. I'll put a breakpoint here. 1963. So we do E op identify operator equal, right. Yes, and then right. then I'm actually going to be able to check what E was. Right, so it's an integer of value 1 because it was originally A. So that's all fine. This comparison is comparing expression items. A bit overkill, but it works. It will compare like for like, whether it's an integer or different types. It takes care of it all. So what I need to do is, I'm not sure what happens with none. Okay, if I follow the pattern that I had before, I did check if it's none, it shouldn't do a check. Okay, so then it's if it's not none, do the check. If the current watch is not none. I actually disagree with that because we could no. All right. Let's just leave it. Okay, that's some debate. None. Right, it worked. Okay, right. So that means that now we're back to the original functionality, but I have refactored the system so that a rule can now have more than one watch. So now let's test the case. This one. So you change C, set C to 3 when A or B change. It's only current here. Right. Expected only one expression item. So now we're in a position to fix that one. That's on this thing where we're evaluating the current watches, and that's because in parsing here, it is just adding an identifier where we could do the add watch, and in fact all what I need to do is the following. We can take that, remains the same and it actually does nothing, but what we do is in here add identifier, finish the expression. So the expression is just a single identifier. We add the watch, we clear the expression. In theory, that should deal with that now. Oh, that's something beautiful. That worked. That's great. It assigned 1 to A. Let's just check that that is actually correct according to the language. On the beginning, we assign 1 to A. When A changed, we assigned 2 to B. We also assign 3 to C, and it happens to assign 3 to C again because it detected both the change of A and B. So that's the only question, is assigned. It should only have assigned it once, unless it's, well, okay, well, that could be a bug. So to verify that, what we're going to do is on change, well, let's see if I did on change A comma A. Yeah, okay, so I say on change A comma A, and it's caused the assignment to C to occur twice. That would be a bug because it shouldn't. Yeah, okay. Well, it's encouraging though, but we have an issue that it's for some reason doing that twice. Now that would be in this code here, execute dependent rules. What I'm going to do is comment out this one, and we're going to do A comma A, and we're probably going to see, yeah, it assigned 2 to B twice. but we only have one case where it's applying dependent rules, so that makes it easier for me to debug this. Put a breakpoint in here, and then we're going to see what we get. This is a rule with a begin. No, it isn't the only case because there's the begin. Okay, and then the next one that we get is another begin. Why was there two begins? That's weird. Did I have more than one begin? On begin. I'm not sure why there are two on begins. It may be an internal one. Assigned one to A. Begin. No, it always goes to the same place, so I can't really rely on this. The debugger lying to me again. Does it ever execute this code? It's got to. Right, yeah, they see? Once again, the debugger lies. All right. Bool changed equals false. Watch indices. Okay. It did that, and it did a break, and it changed. Aha! I know why. It still has to go through all of them. I can't break. If I break, then yes, it's true, it doesn't need to check the others, but it actually needs to copy them over. Right? It actually has to copy them over, otherwise what happens is it's not up to date, and then it'll update it the next time. So, okay, yeah, well, not what I expected, but I think that should fix it. Let's see. Boom! It is fixed. Cool. Alright. So, we'll put the test case that we had here back in. And there is still 2 assignments of 3 to see. So, let's just see. That could be because of the way I did this. Let's try A, comma A. Right, but in this case there's only 1. Why is there 2 assignments? Because it assigns 1 to A, which triggers assigning 2 to B, but the assigning 2 to B triggers an assignment of 3 to C. No, when A changes, we get both this one and this one executed. But then the following time, because B changed, if we get this executed again. That is actually correct. All right. I think I have implemented what I wanted to do. Let's see if this works. I'm going to put that function back in. We're going to initialize our cube, and this was the thing that didn't work before. I couldn't do this expression. Now I can, I hope. Let's see. And boom, that is sad. The reason is that it's not coping with the dot. So the problem now is that we've got an issue with the language, because I'm saying a W expression is an identifier, but that's actually not quite true. A watch expression is actually a path. I need to have a dot. So op dot. So as it happens, I could create something called the W identifier, which permits the use of a dot. This is a hack, but it will work because, and it'd be good enough for now. So what we then need to do is we say that's a W identifier. Let's just see if that works. Yeah, I really didn't like that. Okay, so let's just try this by itself first of all. No, it doesn't like it. Okay, let's try X, Y, Z. Does that work? No, it doesn't. So let's put this back the way it was. Oh, it really, okay. Let's get rid of that. Maybe that's causing a problem, I don't know. Alright, well, that was a bit unexpected why that changed things. So a W expression is an identifier. And I just created something called the W identifier, which, oh, that's a bit weird. Okay, that works. It's just the parsing. I think the tokenizing, if I make this different, it just screws up the tokenizing. Yeah. Okay, so I need to think a little more carefully about this. Can I just put this in literally? Wrestle a little bit with the, this is the Antler language definition file I'm working in. I think I'm not permitted to do that, but we'll see. No, it's like, yeah, okay. Identifier. I could specify this as op dot identifier, like so. This might work. Well, it certainly didn't upset the thing anymore, but now the question is, can I do cube dot pos dot x Wow, it accepted that. So let's put in the code that we want. Cube .pos.y, cube.pos.z. For now, I need to make it so that when this cube is made, this rule gets added, and that's because I'm having to add it explicitly right now. But that's the kind of next thing to deal with. On change frame count cube pos y equal cube pos y. No, I'm just reading random bits now. Right, on change cube. Right. What I want to do is just put a breakpoint in somewhere. Execute dependent rules in here, and just, well, no, because evaluate current watches. Let's put a breakpoint there, and then I can look at this value. It's an identifier. Okay, what's the next one? That was graphics cleared. Text cube.pos.x is the name of the text. It's the only problem is, right, this will parse, but it won't work. Why? Because what it's trying to do is something that is actually not legal. I can't just dive. Oh no, I could. Oh no, it will work. Cube is in fact in the global scope because it was defined here, so I think actually we should be good. It looks like it's going to work. Or should work. Oh, it is. It's moving. Aha! I didn't realise it was actually. It is working properly. It's moving. Look at that. Wow, amazing. Because right, the mission was to be able to do this construct where you can separate these things by commas. It's working. That is nice. That was almost too easy. Should we test it properly? Okay, right, so let's do X, move it in the X. That's a fairly good impression of it working. Let's move it in the Z. So, okay, on frame count, we could do, I don't have yet any sort of vector sort of thing in here. So if I want to move it in all three axes, I literally have to say this. I'll be on X. So this should move on all three axes. That is looking nice. Well, that's that done. The next step is going to be to create something in this function. Ooh, what's going on here? Video card freaking out. Would be to create this rule, and that would actually work. I don't know how to. I mean, if I say on It's just an issue that if I go and do this, which it might be what one thinks that one should do, the problem is that would be executed when you make the cube. So I could use this as a new language feature, like add, change. And so what that would do is add the rule when I make the cube to say that the position needs to be updated. And then if I did that, if I implement something like that, then I can get rid of this line. And so when the cube is made, so the rules for the cube are also specified. So this is like a constructor, and it kind of, you've got the data of the cube is all set up. I think technically I need to say this on begin. What this will be an example of is self-modifying code, because the point is that the code, a program in Phi, is really just a set of rules, and so those rules are dynamic and can be modified in real time. So this would be on begin, you know, add this change. One problem we've got is that, does it add this rule? Well, yeah. Well, actually, actually thinking about it, what we need to do is look at the built-in functions, and then we see that when we make the cube, it actually creates whatever you've passed in dot created. So in fact, to be robust, because the point here is that you can't, the order of execution of these instructions, you know, they are not you can't rely on them. So I suppose when we make the cube is like on begin, make graphics cube, right, on change of what we're referencing dot created, because that is created by the code internally that creates the cube. So this is saying when we begin the function make cube, we make the cube, and continuing in the function make cube, once the cube is made or created, then X, Y, Z, these are initialized. Right? And then what we want it to do is update the position. You do this. This would be the good program, I think. So on begin, you make the graphics cube, and we also add a rule that says when X, Y, or Z changes, we update the cube position. And once the cube has been created, we initialize the position. So we make the cube, we add a rule that we update the position when we change the coordinates of the cube. And that's this on begin, add, change, cube, blah, 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 blah. This rule gets added. And then also when the cube has been created, so that's actually has got to be after the begin, because the first state thing is begin. And then everything in begin is executed first. Then afterwards, because this was changed, because the cube was made, it can then set the position. That's actually really quite elegant. It takes a little bit to get used to because it's very different from normal programming, or rather imperative programming. But the wonderful thing about it is that there's no time anymore. So it doesn't matter how long it takes for any particular thing to happen. You know, when you make the graphics cube, it could take time. Right now it just happens instantaneously, but let's say it took time for it to make the cube. It's just waiting for that to happen, and then once it's happened, it can execute this line. But while it's waiting for this to happen, it can add this rule. This is an example of what happens with sort of multi-threading or with distributed execution. The fact that this could take time doesn't matter, because it can fire this off, and then it will fire this off, and then it will also do this rule, and this rule is being executed at the same time. These can be run in parallel, basically, because the fact that you've got a dependency graph, you can run things in parallel. So an optimizing virtual machine or optimizing compiler, whatever you want to call it. In fact, actually, it's not really even relevant that it's an optimizing. I was thinking, have an optimizing compiler that can sort of just automatically spread work amongst different threads or different CPUs, different systems. But it's not an optimizing compiler. The compiler doesn't optimize anything, really. It's the runtime that cannot do the optimization. So it's a runtime optimization. So you could actually look at this and say, well, right now there are two things that need to run on this. We could run them in different threads. And it knows that it can run them in different threads because of the way that it's expressed. We need to make a cube, and we need to add a rule. They're completely independent tasks. They can be just run, and it knows they're completely independent because it's got a dependency graph, so it can tell immediately what bits of code are connected to or not connected to other bits of code. It has that immediately. And that's one of the things that comes out of this, is that the ability to write code that can be immediately optimized to run on multiple threads without any work on part of the programmer. The programmer doesn't have to think about that anymore. Right? Make the cube and at the same time set up the rule. And it will only do the next thing once everything of the begin phase is done. So if there was like 17 things that need to be done on begin, it could be put out to 17 different threads if it merits it. I think it might be possible to add in the language something that gives clues, hints to the optimizer, or otherwise the optimizer knows. Well, this one is a bit of a special case because that one is in effect a native function, and so maybe native functions you could provide information to the expected execution time, stuff like that, and then the optimizer can take that into account. But this one is entirely language dependent. The runtime system, the virtual machine, should be able to know exactly how much this costs. Oh, well, actually, if it knows how long it takes to do an update position. In this case, the update position has a fixed cost, because it's just a transmission across the network and there isn't any sort of throttling going on. But once these are done, it will pick up the fact that cube was in fact created, because this will have been set. And so then at that point it sets the value of those positions. Then because those are changed, it will update this. So if I actually, this isn't going to run because there's language features which are not implemented yet, but specifically the on begin add expression has not been on begin add change. I need to implement that. But if that's implemented, then in this case it will create the cube, set up the rule, put the cube X position 10. That's done once the cube is created, and then immediately that's changed, this rule will pick up that that was changed, and so it will automatically update the position. This will all happen in make cube, and currently all of this needs to finish before the virtual machine will allow any further execution. So by the time make cube is finished, well, all of this is finished. So then we want to perhaps make it so something happened once the cube was made. And so for that, it's actually quite okay to do on change. Yeah, this works. Cube.created. And we put some whatever instructions are being made in there. Now what happens here then is that when the graphics are cleared, it makes the cube. When it makes the cube, it does its own thing, including checking if the item was created. It actually runs this function in its own virtual machine. When does this exit? This exits when there's no further changes to any state. Well, that will happen after it has set the position, because when that has done, it will update the position, which doesn't change anything. So then it looks at it and says there's no further change in this state. Okay, then we're done. And so it exits make cube. And then this machine, this virtual machine, checks, okay, did anything change? Well, as it happened, calling make cube created a side effect. The side effect was the item created. It's going to see that this I'm trying to keep created, sorry. It's going to see that this has changed, and so at that point it can execute something else. So what I'm running through in my mind is about the execution graph through functions, and the conclusion is it's all fine. So you can actually have side effects, and it can track the side effects. It's like it knows that when you call make cube, it will know exactly what the side effects are. Because make graphics cube creates this side effect and is a native function, for that to work, because it's a native function, there would need to be something in the definition for native functions eventually for us to declare I can change item created, right? And then the compiler or runtime system, whatever, the virtual machine, would know that a consequence of running this could be to change this, and would know it ahead of time. So you can see then it would be able to optimize for that as well. But this was something that was on the back of my mind is like how to handle side effects from functions, and it's just handled. It doesn't have any problem with that. Because there you go. But further than that, the dependency graph is still valid and able to do its thing, so that you could have a system that would optimize this through a function to run on multiple cores. So if you're doing like a water simulation, which would be, that's like a way down the line, but doing like a fluid simulation, you should know which bits of the algorithm are independent and which of them are not, and the ones that are independent automatically farm it out to different threads, and they, boom, that would be great. I mean, it just like you specify in a completely execution, the execution process agnostic way, what it is that you want done, and it just does it. So the more that I keep looking at this, the more when I started this, I was going like, oh gee, it's like, this seems like a silver bullet, like a real one, a real silver bullet that solves so many problems. Yeah, that's a great way of thinking about it. A coordinate system of processes. It could be. I mean, the T2 tile project. At some point, when I think this is, in a position to demonstrate something a bit, I might want to talk to that guy, because the point is that this should work like a dream in a distributed computing context. Because it is a you could potentially run any piece of code anywhere. I mean, that's one of the things I want to figure out at some point, is if I could move, you see this on change frame count line here, right, in this example. It's like, wouldn't it be fantastic if that could run on the viewer? This is huge, if this can be made to work. So let's say I've got the example of the bouncing ball around the screen. So as it bounces on the, trying to move my finger, it's difficult, boing, 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 boing. It's because it's not a mirror, right? So it's bouncing around the screen. Okay, it's clear. It's not a major jump to see how that would be done from what you're seeing here. Okay, in fact, I'm almost ready to demo it. But what I want to do is implement this on begin change, add change thing, right? Once I've done that, I should be able to make the cube bounce around within a region, right? Like Pong, whatever, bounce around the screen. Fine, but then if I can get it right, I can have the two executing systems. One of them is the phi running here, and have phi also running in the viewer. So it's to put phi in the viewer. This is down the line, but put phi in the viewer and have phi here as well. And then it be able to offload one line of the rule, one rule, or any of the rules, but to be to say that, which is an integration step, that step that is move the objects every frame, can you take care of it, viewer? And to transmit that request over so that the repositioning of the ball or the cube every frame doesn't happen here, but happens here, happens in the viewer. So of course you can see where this is going, right? Because if I'm able to put that integration step on a different process, it's not even a completely different thread, it's a completely different process with a communication over the network, right? If I can do it with that, it will work with anything, right? Then you can see how if I had 1,000 objects that needed to move, those 1,000 objects could be spread amongst different threads. But if the process was even more complicated, if it was an involved calculation, for example, you're trying to figure out how, I don't know, some kind of complex, like a, I don't know, Bitcoin thing or whatever, a blockchain thing, for example. It could take time, like it might take seconds to process something or minutes to process something. Then if there is the ability to offload the rules somewhere else, and you can have a distributed system where the rules can be distributed amongst all systems that are able to run Phi, and have a protocol for those, so that you write your program in one location, and the whole system, if it's able to speak to other systems that are running Phi, could on the fly distribute the workload on a rule by rule basis. It's like having the ability to run every line of code potentially on a different thread, different system. And that is, of course, not possible in your traditional languages. And this is like, yeah, these are pretty big claims that this, but it's a claim that it could be possible. I'm not saying it is possible, but I'm saying it looks increasingly likely that it is possible to do this. And that would be just a wonderful thing. You know, you could do like an n-body simulation where you specify a very simple program. Like an n-body simulation, it's not very complicated until you want to optimize it. Then when you're optimizing it, then that's, you know, it's an n-squared problem. If you've got 10,000 stars and you want to simulate them moving in a galaxy, you want to simulate them sort of moving around each other with an n-body, a straightforward n-body calculation, then that's 10,000 times 10,000 or 100 million iterations on every step. And so it starts getting rather slow. And that's just 10,000 stars. So there are ways of optimizing it. Classic one is an approximation that you just ignore beyond a certain distance. You say it doesn't have any effect, right? But if you don't do that, then another way is that you run it on different cores. So you can use something like CUDA, whatever. But what if you could just write it and then say, look, that's what needs to be done. Here are your resources. So there is like, I don't know, people, it's like the SETI, you remember SETI, the search for extraterrestrial intelligence at home, SETI at home, I remember that. Everybody was looking for these signals, checking these signals on their machines. I don't know if it's still running, and they're looking for extraterrestrial signals by searching for a Gaussian distribution of, as the thing. I think we used the Arecibo observatory, but that fell down, didn't it? But I think it was that one that it used originally. And but then that was running. That was distributed on everybody's PCs. But you can imagine that if people were running Phi on there and they gave the permission, you could have a kind of a central thing, like a big supercomputer. You send to it your instructions in Phi. This is your Phi program, and it can just go, well, let's get started, shall we? And it could optimize it to run this, say, n-body simulation on hundreds of thousands of computers that just are connected to the internet, and that sends it out, gets back the information, and it just runs. It's got to be worth a try, right? It's got to be worth a try. Anyway, I'm going to leave it there for tonight. Thanks a lot for watching. Although I suspect it's only Mike. Well, I can't say only Mike. I mean, Mike is probably the most important member of the audience, so it can't be only Mike. But oh dear. What are we going to end with? I need the video. Your channel. Oh, I know which one I'm going to do. Let's have a look at managing the videos. I'm going to do no, so I haven't got one. I've Solid Air. Solid. How about this one? Yeah, why not? There we go.
Although it's quite nice to do like
you know, it's quite nice sometimes to just sort of do a video, just no production or anything. You just sort of like, yeah, you can tell this is early YouTube. It's 2007, where people cared, you know, about such things. Quite funny. 14 years ago. Cover of Solid Air. Take care, everyone.
It's quite nice to do like things a little bit more professionally. Try to sort of mix the audio down, do a bit of video editing. Sometimes it's also nice just to pick up the guitar and do a blog-like video thing with a song. I'm going to do that now. This is
Blog-like video.
tune by John Martin, song by John Martin called Solid Air.
Listen to me,
John
blog-like
Martin's,
video.
big
Jeez.
influence for me musically. It goes like this.
You've been taking your time, living on the solid edge. You've been seeing it blue, looking through solid air. You ain't seeing it true, you're looking through that solid air. I don't know what's going on in your mind. No, you don't like what you find when you're living on solid air. You've been thinking too deep, thinking on solid air. You've been missing your sleep, you're dreaming on that solid air. No, what's going on in your mind? No, you don't like what you find when you're living on that solid air. You've been painting it blue, been looking through solid air. Seeing it true, you're looking through that solid air, and I don't know what's going on in your mind. No, you don't like what you find when you not know you. I love you. I could be a friend. I could follow you anywhere.
looking
Hello Dino.
solid air. Don't know what to do when you're looking at that solid air. Don't know what's going on in your mind. No, you don't like what you find when you're living on that solid air. Now I know you, I love you, be a friend. Now I know you, I love you, I could be a friend. You've been stoning it cold, not lost solid air. You've been making it old, and solid air. I don't know what's going on in your mind. Living on that solid air. Well, I know you, I love you, I could be your friend. I know you, I love you, I could be your friend. You've been thinking too deep, thinking on that solid air. You've been missing your sleep, you're dreaming on it. I don't know what's going on in your mind. No, you don't like what you find when you're living on that solid air. I know you, I love you, I could be your friend. I know you, I love you, I could be your friend. Don't keep painting it blue. No need to. I could be a friend, right to the end. Right to the end.